So many of us might be familiar with the announcement that looks something like this. We're used to seeing it every year when a new version of Ruby is released. And as Mats was talking about in his keynote this morning, this year's version is going to be Ruby 3.2. And we'll get an announcement that looks something like this again. It comes out every year on Christmas, so the date will be slightly updated. And maybe some parts of the announcement will also be updated. And pulling together these slides was actually the first time I noticed that Ruby is all of our best friends. I don't know if anyone else had seen this before. But with this announcement comes a whole new set of features, right? With each Ruby version, we have new features. And we might be used to, from our own development, when we ship kind of new version releases or new application versions, we have a whole bunch of features that we're shipping to. And some of them are really visible to the end user, and others aren't, right? Others are more of performance improvements or security improvements or things like that. And similarly, each year when we ship a new version of Ruby, we have some features that are really visible to the end user, right? Some totally new features, maybe pattern matching or reactors or something like that. And other improvements that are more behind the scenes, right? Security improvements or performance improvements or things like that, which will make our experience better, but we might not necessarily notice or interact with in the exact same way. And what we're going to talk about today is something that's going to fall into this latter category. So I've been working for the past few months alongside Aaron Patterson on implementing a technique called object shapes in C-Ruby. And it'll ship with Ruby 3.2, right? It'll be there behind the scenes, but it's not going to be something we're going to see in the same way we might see pattern matching or see something like that. But we'll still go into exactly what it means, how it's going to impact performance, and the kind of behind-the-scenes look of what object shapes are. I'm Gemma. If I haven't met you yet, I would really love to. I work at Shopify on the Ruby and Rails infrastructure team, and that's where I've been able to do this work. And over the course of today's talk, we're going to answer these three main questions. So first, we'll talk about what object shapes are. Then we'll go into how they're implemented. And then lastly, we'll talk about the benefits of object shapes. So why implement them? Why did we make this change? So first, to begin with, what are object shapes? Well, when we think of object shapes, we might think of a diamond or a triangle or an oval. But this is not what we're going to be talking about today. We're not talking about literal shapes. When we say object shapes, when we say object, what we really mean here, what we're referring to, are Ruby objects, right, that we're quite familiar with, an object.new or something like that. And when we say shapes, it's kind of in these quotation marks. It's not literal shapes. It's a name of this technique that's been around actually since Smalltalk. And so each Ruby object, we're going to say, has a shape. And the shape represents the object's properties. So what are some examples of properties? Well, something like the frozen status, whether or not the object is frozen, or instance variables on the object, so we can access its instance variables. And when we talk about this, the reason we want a representation of the object's properties is because Ruby is a dynamic language. So there's some languages like Java where we'll know all the information about an object up front, but in languages like Ruby, this can change through the course of running our application, right? We can add more instance variables to an object or freeze it or do things like that. And its properties and the shape of it will change. And so we can use this concept of a shape to say, hey, this is going to represent all of the properties. And we'll dig a little more into what that means. So we're going to begin by looking at this example. We have a class post with a title and an author, and we're going to create an instance of this class post. And we'll look at its shape. Again, the circle is nothing to do with an actual circle, just to hold the information we're about to talk about. So the first thing the shape of this first post is going to have is the instance variables. So we see we have two instance variables, the title and the author. And those will be our instance variables on the shape. And the next thing the shape is going to have is a frozen status. So if we were to freeze first post, the frozen status on this shape is going to be true. And shapes have IDs, which uniquely identify them. So the ID of this shape, let's arbitrarily say, is 6. OK, so that was one example. Let's walk through another example. We have this user class. Similarly, we have an instance of it. We know its instance variables are these name and login instance variables. Those are the ivars on the shape. And we'll give it, again, arbitrarily the ID of 31. If we have this separate class admin, which is very similar, you'll see it has the exact same instance variables, but it's separate to user, what's going to happen in this case? So we have our instance of admin, and we can see it has those two instance variables, name and login. But these two shapes have the same properties. And so what happens if they have the same properties? Well, they're actually the same shape. And this is a critical point, that these two instances of different classes can share the exact same shape. And we said a shape of an object transitions with new properties. So let's look at how those transitions actually happen when we add new properties to a shape. Everything starts at what we call the root shape, which has an ID of 0 and no instance variables on it. It's practically empty. And so when we initialize first post, when we first call post.new, we'll start at this root shape. Then when we set the title to this very creative title, we'll transition through an edge named title to a new shape. And that shape's going to have ivars just title and the next ID. And we'll make that transition. And then similarly, when we set author, we'll transition again through the instance variable author to a new shape with instance variables title and author and the next ID. And we'll make that transition. But if we had this post class split into two methods, where we set the title in initialize, but then we set author in a different set author method, well, we know then first post would have this shape with ID 1, right? Because it just would have the instance variable title. But what if we had a second post, and on that second post we called set author? Second post would have a shape with ID 2, whereas first post had a shape with ID 1. So this is another critical point here. Two instances of the same class can, as we're seeing on this example, have different shapes. OK, to look at another class here, say we have an image, which also has a title. But instead of an author, it's going to have an image URL on it. We know by now when we call image.new, we'll start at the root shape. We'll transition through this edge with name title to the shape with ID 1. And then we're not going to take the same author transition. Instead, when we set image URL, we'll make a new transition to a new shape. And the instance variables on this shape are going to be title and image URL. And it'll have the next ID, and we'll make this transition. And you'll notice the shapes form a tree. If we were to run some version of the snippets we've had so far into Ruby code, we'll see a tree that looks something like this. And we're going to get more into specifically what's going on here and what everything means. But when we were saying the shape of an object transitions with new properties, and we were saying the frozen status can be one of those properties, let's look at what that would mean on our shape tree. So say we have an anonymous post, anonymous because it only has a title and no author. And we had an instance of anonymous post. We would start at the shape with ID 0. We would transition through our title to the shape with ID 1. And then say we were to freeze our anonymous post. We're now at the shape with ID 1. We're not going to take the existing transitions. We're going to instead transition through a frozen edge to a new shape. It's still only going to have the instance variable title, but it'll also be a frozen shape. OK, so that was an overview of what object shapes are. The next thing we're going to discuss is how we implemented them. So a little behind the scenes of the implementation details itself that'll allow us to then talk about what the benefits are. Why did we implement them? So first, how do we identify shapes? and we'll get to, again, more of the specifics on this tree momentarily. But we can see here we have IDs on each shape. So each shape has a unique identifier, a unique ID that's going to say, hey, this shape with this ID has exactly these properties. And we have room for quite a few different shapes. We can run Ruby on 2 different types of machines, on 64-bit machines and on 32-bit machines. Most of the time, we're running on 64 bits. All of your production applications, I hope, are running on 64-bit machines. And on 64-bit machines, we can use 32 bits for shape IDs. 2 to the 32 is going to give us about 4.2 billion shapes. On 32-bit machines, which are much less common, although WASM, which Mats was talking about, runs on 32-bit machines, we use 16 bits for shape IDs. And 2 to the 16th is about 65,000 shapes that we'll have on 32-bit machines. And just to contextualize these numbers, so on Rails Bench, which is a benchmarking suite for Rails applications, we have about 10,000 shapes. I also ran object shapes on Shopify's Monolith, which has got to be one of the biggest Ruby applications out there, on the test suite, and it was 40,000 shapes. So both of these would comfortably fit within 32-bit machines and will definitely fit within the 4.2 billion shape threshold. OK, so the next question we might have is, what information is encoded within a shape? Right? I've alluded to these properties. What's really going on here? Ruby, as some of us might know, is written in C. And so we have this RB-shaped struct. And it has a few different properties on it. And we'll walk through what each one means using our shape tree diagram from before. So to begin with edges, an ID table is basically a hash or a map from keys of some value to values of different value. So we'll start, say we're looking at shape with ID 5. We can see it's going to have those 2 red arrows will be the two edges out. The keys are going to be the values, they're login and frozen, and the values are the shapes. So it's telling us which edges exist on a shape. The next is the edge name coming into the shape. So again, if we look at this shape with ID 5, the edge name, or that property transition, was name. Next up is the instance variable count. So how many instance variables are on this shape we store, and we'll see in a bit how this comes in handy. And you can see here the number of instance variables we have on these shapes, 2 on shape with ID 2, and also 2 on shape with ID 6. The next thing we have on a shape is its type. And shapes can be 4 different types. We'll go through what each one means. So to begin with, we have the root shape, which we've already discussed, is this empty shape at the beginning. All objects start at this root shape, right? Because at birth, they have no properties on them. Next are IVAR shapes. So all of these other black shapes in this diagram are IVAR shapes. And what that means is they've taken an instance variable transition. So they were created through instance variables. Next are frozen shapes. So the 2 blue shapes here are frozen. And you'll notice that they're leaf nodes, right? And this, if we think about it, makes sense, because we know if an object is frozen, we're not going to set any more instance variables on it. So we're not going to make other transitions to other types of shapes. And another thing you might notice is they both have these frozen transitions leading into them, right? To get a frozen shape, we must have made a frozen transition. The next type of shape is what we call this undef, or undefined shape. And it's quite an interesting case. It's this orange or yellow shape at the end with ID 4. And you might have noticed we have title twice here, right? We had 2 title transitions to get to this undef shape, which doesn't really make sense given what I've already said, right? If we have one instance variable, instance variables uniquely dictate a shape. So how did this happen? How could we transition to this undef shape, and what is it saying? Well, to go back to our post class, let's say we have a post, an instance of post, first post, and we set the title on it. we know now we'll make this transition from the top shape, from the root shape with ID 0, through title, to this shape with ID 1. But then something we can do in Ruby, again, since it's dynamic, is we can remove the instance variable. We can say, actually, we didn't want this title thing. And what's going to happen here is our shape will transition through that same instance variable to a shape with an undefined type. And we'll see in a bit where that comes in handy and how that's actually going to allow us to reduce code complexity overall. And the last thing we have on a shape is a parent ID. So this shape with ID 5 that we've been looking at, its parent has ID 0, so we'll store that also on the shape through this edge. So we've talked now about what object shapes are and about how they're implemented. And the kind of most important part of this talk is why. Why did we implement object shapes? So we'll go through several different benefits of object shapes. We'll go through each of these one by one. So the first is increased cache hits. Right? We know caching is a good thing. We know that by default, and we know if we can add more cache hits, that's going to be a good thing. But let's look at specifically how that happens. So with object shapes, we changed how caching works on instance variable reads and writes. So every time you set or you access an instance variable, that's going to work slightly differently in Ruby 3.2 than it did in any prior version of Ruby. But to understand the change, we first want to understand how it works today, right? How this works in Ruby 3.1. So if we go back to our post class and we have our first post, where are these instance variables actually stored, right? When we're setting instance variables, Ruby or something must be keeping the values somewhere because we know we can access them, right? So how is this actually happening? Well, what happens behind the scenes is each instance of a class, each instance has its own instance variable array where it stores the values of all of its instance variables. And then Ruby gives us per class this map of instance variable names to what index they appear in the array. And we'll walk step by step through how this works. So when we set title to the string A, Ruby's going to say, hey, we're trying to set title on this post class. Does it exist in this instance variable names map? No. Let's put it in here at the next available index, which is 0. And then at index 0, in our specific instance of our specific first post instance variable array, we'll put that value. So that's where we're going to store the value of the instance variables. To walk through it again, when we set the author, what we're going to do is say, hey, have we seen author before on a post? We'll say no. We'll put it into this map, into this hash, at the next available index. And then at that index, we'll write in the value b here. I don't know anyone named b, but maybe they exist. And so the one thing you might have noticed here is that we're going to have to do a hash lookup over and over again. And it's not the most expensive operation, but it's also not cheap. And we know when things aren't cheap, the solution there is to cache them, right? So instead of having a hash title over and over again, we can cache this lookup. And what we're going to use as our class key, as our cache key, is the class. This is what Ruby 3.1 already does today. So it says, hey, when we set title on the post class, the index that we were looking at was index 0, and we cache this. And similarly, when we set author on the post class, this index was 1, and we cache this as well. And this is great in most cases. But what happens if we have something like this? Front page post inherits from post. And we have an instance of front page post. Well, now the class is going to be different, but the initialize method is exactly the same. And so we're gonna have cache misses, right? Because instead of having the class post, we have the class front page post. And these cache misses can be costly. OK, so that's the current state of how it works today. what are object shapes changing, or what's different here? Well, we no longer are class dependent in the same way. So we actually get rid of this map from instance variable name to index overall. And instead, we replace it with our shape tree, which should look familiar by now. And we'll see now how all of the things we've talked about before can come into action, into practice with this cache lookup. So if we were, for example, so what we can do is remember the IV count from earlier is going to tell us how many instance variables we have. We can use that to get the index, right? We don't have to store the index in the same way because it's going to be just the IV count minus 1, right? We're 0 indexed here, so we subtract 1 from the IV count, and that'll give us the index. And instead of using the class as the cache key, we can use the shape ID as the cache key. And you might be able to see how this is going to lead to more cache hits and fewer cache misses. So to walk through concretely the example again, when we set the title instance variable, what we're going to do is we'll start, our object is starting at this root shape. It's going to transition through title to this shape with ID 1. We know the IV count is 1 here, so our index is 0. And at index 0, we'll then fill in our value. And then what we're going to cache here is, hey, shape with ID 1 has index 0. And again, the ID is coming directly from the shape we're on. And the index is the IV count minus 1. And it's referring to where it is in this instance variable array. Similarly, when we set author, we're going to start at the shape with ID 1 that we were just on. We'll make that transition through the author edge to a shape with ID 2. IV count is 2, so we know that means our index is 1. And at index 1, we're going to put our value b right here. And then we can cache, hey, shape with ID 2 has index 1 in our instance variable array. And we can see the shape is coming right from this shape ID. The index is the IV count minus 1. And it's referring to exactly this point. And now, if we have our front page post, because we're no longer class dependent, but instead our cache is based on the shape, we know we'll make those exact same shape transitions in the initialize method. And so where we previously had cache misses, we'll now have cache hits, which is going to give us increased cache hits overall. The second benefit of object shapes is decreased code complexity. And there are quite a few ways in which we've decreased code complexity, but we're going to talk about 2 specifically. The first is reduced frozen checks in instance variable setting. So this is some pseudocode of before object shapes, so in Ruby 3.1, how setting an instance variable is working. It's going to take 4 arguments to set an instance variable. The object we're setting the instance variable on, the cache, which we just discussed, the instance variable name, so what instance variable are we setting, and lastly, what value are we setting it to. And the first thing we'll do, as we've talked about, is check if the object is frozen, right? We know we can't set an instance variable on a frozen object. Let's check right away. Then we'll do this cache check that we talked about, right? If we have a cache hit, we can just keep going. But if we don't have a cache hit, we're going to need to do our expensive computation, our slow path, and find the index, right? And that's what we talked about here, of looking up the index and this hash lookup that wasn't cheap. And so we'll do this expensive computation. And then our last step is going to be to set the instance variable to the value. With object shapes, this looks quite different. So the first thing we'll notice is that we're no longer comparing the class to whatever in the cache. Instead, we're going to compare the shape ID. So we'll say, hey, unless object.shapeID is the same as the shape ID in the cache. And our expensive computation is changing, right? That's going to change to iterating up this shape tree to find the index. So say we were at shape with ID 6, and we were looking for the index of name. We would go through this login edge, say, hey, that's not it, to shape with ID 5. Then we would see name. We would take our IV count -1, and that would be our index. But something we know is that, and this is a critical point coming up, the frozen status is encoded in the shape, right? The shape is already telling us if the object is frozen or not. So we only actually need to check this on the slow path. Consider that shape with ID 5 was the one that was cached. Say this is the cache shape. We know that because it's cached, we've already transitioned from this shape, right? We've already set an instance variable on this shape. That instance variable login, for instance. And so by definition, the shape can't be frozen. In order for the shape to be in the cache, it cannot be frozen. And so we don't have to do the frozen check at all on the fast path. And we can move it only into the slow path, right, where we're already having to do that expensive computation. And so we've made our fast path faster and reduced code complexity because we're removing this frozen check from that path. And then our last step, and our only step in the fast path, will be to just set the instance variable to the value. The second thing I want to talk about as an example of how we decreased code complexity by introducing object shapes are removing undef sets in object allocations. Now, what does this mean? Undef might sound familiar from, hopefully, from the earlier slides. Say we have we're calling object.new, right? It's something we've done many, many times, or some class.new. We'll get back some object. And what's going on behind the scenes is Ruby is going to give us some piece of memory. And within that memory, it's going to say, hey, here's your space for instance variables. Some amount of instance variables. What that number is complicated. But some amount of instance variables. And then we can set these instance variables, right? We know by now we can set, say, instance variable A to the value nil. And it'll say, OK, your first instance variable, we know this, is now going to be nil. Something else we know we can do is call instance variables and just get back A, right? This makes sense. This snippet makes sense. And we know that A was this nil from our first case. But what's going on here, right? How did Ruby know not to give us back whatever happened to be in here? And it's because Ruby had already filled this in with undef. Undef and nil are not the same thing, and Ruby doesn't expose undef to us. Some other languages, like JavaScript, will show us undef and nil, and it's this funny thing where they're different types, but maybe, what do they mean, right? In Ruby, we just have nil. We don't actually see the undef. And so what that means is when we were calling object.new, instead of just this blank instance variables, we were filling all of these with undefs. And this operation of filling these undefs has both a performance and a complexity cost, right? Now we're going to be checking for undefs all over the place. And we have the performance cost of every time we allocate a new object, which happens quite a bit, we fill in all these undefs. So what's different with object shapes? Well, we know we have this undef shape, right? That must come in handy somewhere. And we know when we're looking at our instance variable array, we're really just iterating up the tree, right? So because we're iterating up the tree, we can account for whether an instance variable is defined or undefined through that way. And when we're calling object.new, we don't need to pre-populate with any undef values. We no longer need to do this at all because we're not looking in here, right? We're looking up the tree to get all the indexes. And so we can remove both the performance and the complexity cost there. I'm sorry about the audio. I don't know if I'm doing something weird. The next benefit I want to talk about is that it's beneficial for JITs, for just-in-time compilers. Matt's talked briefly about JITs. I don't want to go too deep into it, but if you have questions here or you want to talk about YJIT or anything JIT related, please come find me afterwards. We'll just look high level. YJIT is a just-in-time compiler that my team at Shopify, Maxime specifically, led work on and put out last year. And the code it generates is like another way to think of this caching thing, right? It's caching instructions or kind of thinking ahead of where we are to try speed up our code overall. And shapes help this even more if we look at instance variable get. And we're going to look at some code, but you don't really need it. We can fuzz it out kind of. Without object shapes, this was what get instance variable looked like in assembly. And with object shapes, it looks like this. And the big takeaway that I want you to get from this slide is that with object shapes, there's just less. There are fewer instructions, fewer comparisons, and fewer memory reads. And all of these things are going to make our code faster with Wjit. And there's even more potential here to make further improvements with shapes. And so the last thing we're going to talk about is performance, right? Let's look at some performance and some benefits. And we'll look at both RailsBench, which is a popular benchmarking library, and at micro benchmarks. So RailsBench, we can see this box plot. We measured average requests per second over 10 runs, where higher is better. And Ruby master, Ruby head was on the left, and Ruby with shapes is on the right here. And you can see shapes is higher. It's also more precise, right? You can see on the box plot, the values are closer together. And shapes is faster here on RailsBench in a significant way. The next thing I wanted to talk about is a few micro benchmarks. So Ruby has micro benchmarks within it. And the ones we cared about were the ones that were setting or getting IVARs of different types. And so that's why the names we'll see are a little different, but setting or getting IVARs. And this chart shows object shapes divided by master, which means that any value greater than 1 means shapes is faster. Any value at 1 or about 1 is the same speed. And less than 1 means master is faster. But these benchmarks have quite a bit of variability. So anything kind of within 2% here is a wash. It really changes run to run. But we can see we have quite a few benchmarks where shapes is faster, and 2 benchmarks at the top here where shapes is significantly faster. And I want to end on drilling into one of these benchmarks. So this VM IVAR init subclass benchmark. If we look at the code here, this is what it looks like, and we'll walk through what it's doing. The crux of the benchmark is measuring this b.set IVARs and c.set IVARs over and over and over again. And if we look up, we can see that class B and class C are both inheriting from class A, but they're different classes. So this is exactly the case we were talking about earlier, where we said we'll get cache misses with the way Ruby used to exist. And with Ruby with shapes, we'll get cache hits in these cases. And we're seeing it's more than 2 times as fast with object shapes, which is a significant improvement here. So we answered 3 questions today. We looked at what object shapes are, at how they're implemented, and lastly, we looked at why object shapes, what are the benefits here. Thank you so much. I want to especially thank Aaron Patterson, who's worked on this alongside me. If you're interested in following along, shapes actually recently merged into Ruby, but I'll post about it likely on Twitter. You can follow me here. I also just wanted to shout out, if you like conferences, which I would assume is all of us, there's a new conference that I'm organizing in a month called RubyConf Mini, which will take place on the East Coast of the US. If anyone is interested in coming, please look it up. And lastly, I just wanted to shout out, I also organize a women non-binary Ruby community called WNB.RB. We're virtual. If you're a woman or non-binary person, please join us. We'll also be meeting right after this today and going to a coffee shop together to get to know each other in person. Thanks so much again.